Okay, Assalamualaikum warahmatullahi wabarakatuh. Our lesson for today, so we discuss first exercises lesson 5 based on to we are focused on to the lesson question number 4. So according for this question exercise lesson 5, okay, dia minta dekat sini deduce the relationship pair as enantiomer, cis trans isomer, conditional isomer or the same molecule. According to the several question given, so the task question, they want you identify which one the pair according for the structure given. So according to the question A first, okay, so I draw it first here. So, according to the question A, if this question given, so you must be draw in form of a 3D structure. So, the meaning of the 3D structure in our drawing, you must be sure this is a plane projection, plane. This is a front projection and this is a back projection. So we have a pair of the structure. I label the first is A and for the second is B. So you must be compare what is the criteria relationship between A and B structure. So basically, okay, you must be identify first is that the compound consists a chiral carbon. If compound consists the chiral carbon, means maybe the compounds can form enantiomer. So, according for the structure E here, okay, so my suggestion here, you must be choose the structure for the A. So, we need to compare structure A to B. Means if we draw here this hydrogen atom as a plane projection, so means we pick here, kita pegang area hydrogen, so kita fokus kepada A first. So according to the structure E, okay, you must be identify first is that the structure A apa relationship dengan structure B. So apa kita nak buat adalah you must be check it by in form of a 3D projection. So we try to rotate it. So when we rotate, the analogy ni as here. Okay. So according for this carbon atom, okay, if I form into the circle, okay, so I divide by 3 area. So this is your chlorine atom and this is your fluorine atom and this is our Br atom. Okay, fluorine atom here is the plane projection, bromine is the front projection and the chlorine is the backward projection. So what should you do when during you want to trace area for here? So you must be rotate. So macam mana kita nak rotate dia adalah kita cuba rotate supaya boleh jumpa the position of the atom similar for the given for the B. So dalam soalan the structure for the B, saya fokuskan kepada bromine atom. Okay, bromine atom A in front projection, but structure B structure in the back projection. So what should you do? So according to structure A here, we try to rotate it. So rotate one side means it rotate 120 degrees. So bila dia rotate, apa berlaku? Okay. The backward projection here is become bromine atom. And then what happened? The front projection become fluorine atom. And the plane projection here can be formed chlorine atom. So when we compare it with the given structure, so we draw it again. So this product can be formed. Plane here remaining for hydrogen and this part chlorine atom and this fluorine atom and the backward is a Br atom. So this is our product when A already rotate. So when we compare the product of the A to the B, So, kita angkat dia, letak dekat dia. So, apa kita dapat? The both molecule here will become super impossible. Means dia bertindih tepat. H bertindih dengan H. Okay. Bromine atom dengan bromine atom, fluorine dengan fluorine, and chlorine dengan chlorine. Whether this compound already consists of chiral carbon, but after rotation occur, the product can be formed as here. So this is our after product of rotation. Chlorine, fluorine, bromine. So this is product after A rotate. Okay, and then the remaining structure B, A, chlorine atom, fluorine atom, and bromine atom. So this is B structure. So when we compare together, okay, A and B, we can make a conclusion. A and B, okay, are not what? Are not. This is it mirror image reflection occur? Okay, are not enantiomer. Okay, ataupun we can state also are super impossible. Okay, which is they are same molecule. If they are same molecule, A and B also have chiral carbon. So careful So we can state that A and B not enantiomer, but they are only same molecule. Okay, so now we are focused on the question B. Okay, so how we tackle for this question? We try to label it. The first compound is A and the second compound is B. So we are focused, the solution here, we focus on the structure for A. So what happened? We try to rotate the structure A first to ensure we try to compare with the structure B. So what happened here? The upper side is the hydrogen. So, pandangan kita adalah daripada atas. Apa yang berlaku adalah, if I focus into the circle shape here, so we divide by 3 area. Backward projection for the structure A is the chlorine. Front projection here, our front projection is Br. bromine, and the plane projection is fluorine. So what happened for here, we need to rotate it to find out what happened to the pairing for the structure B. So I focus for the bromine atom here. The structure A, bromine atom in from the front projection, but structure B inform a backward projection. So what happened? The structure A, I rotate it here. Okay, anti-clockwise according to the 120 degrees Z. So, what happened after rotation occur? So, the product can be formed. Our plane projection here become bromine atom. Backward projection here will become fluorine atom after rotation, and the front projection is a chlorine atom. So, I try to convert into the 3D structure. So, the plane upward here hydrogen. So, plane here bromine atom. Front for the structure A after rotation become chlorine. And the backward is fluorine. So, this is product after A rotate. And what happened? We compare with the structure B. In structure B, we have upward plane is the hydrogen, chlorine, and the front projection is a fluorine, and the backward projection is bromine. So, what happened? We compare the product form. Is it same? Not. So, what happened? This remaining product, we try to rotate it again. So, according to the structure B, we are focused to the bromine atom. It must be in form of backward projection. But the first rotation we identify bromine in a plane projection. So what happened? We try to rotate it again to ensure bromine will become backward projection. So we rotate again another 120 degrees. So after rotation, product can be formed. So we try to find out our backward here become bromine, and then the plane projection chlorine, and the front projection here is fluorine. So after the rotation occur, we try to redraw again in form of final product form. Chlorine, front projection for fluorine, and the backward projection of the bromine. So this is product A after rotation. Okay, so we compare with the given structure of the B. So your plane projection is the hydrogen and chlorine, and the front projection here is the fluorine, and the backward projection the bromine. So when we compare the rotation, the product rotation of the A and the given structure of the B, we can trace the relationship between A and B. A and B are mirror image. At the same time, the both structure also have a chiral carbon. So, we can make conclusion A and B are pair of enantiomer due to the non-superimposable. So we conclude that the answer for the B, the pair of them are enantiomer, because when we compare together A dengan B, dia tidak bertindih tepat. Okay, so what happened to the structure for the C equation? So when the C equation here, we are trace here, what happened to here adalah kita trace apa similarities of them. Pertama, kita boleh check terus. This compound, is it chiral carbon? So, hydrogen, 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 bromine and fluorine. So, we can state that, okay, the answer for the C equation, okay, they have, sorry, they are, they are a chiral molecule. Why they are a chiral molecule? Because they cannot have chiral carbon. So, if they do not have chiral carbon, they are classified as a what? What the relationship of them? So, dia adalah same molecule. Is it same molecule? Yes, same molecule. Is it same molecule? And at the same time, they are super impossible after the rotation occur. Okay, next. According to the structure for the equation D, so we can find out the carbon-carbon double bond means we can find the criteria, the restricted rotation of the carbon-carbon double bond, and we need to trace what happened to each carbon in the carbon double bond. It have a different atom, so therefore D can form cis trans isomer. Okay, what happened to the equation of the E here? Is it cis and trans isomer also? So restricted of the carbon-carbon double bond, each carbon have the two different groups, similar for this part. But the second pair here, is it cis trans isomer? No. So the both compound we can classify as a constitutional isomer. Constitutional. Constitutional isomer because the both compound have a same molecular formula but different in. Okay, now we are focused to the aim of our lesson based on to the lesson 6. So in lesson 6, we are focused to the concept of the reaction in the organic compound. So this is the most important in our lesson. So according to the reaction, this is the process of the covalent bond cleavage, either in form of homolytic or heterolytic. So you must be differentiate between either hetero or homolytic cleavage, and then state the relatively stability, either primary, secondary, tertiary, the intermediate species, carbocation or carbanion. Compare stability, define the species of the process according to the electrophile, nucleophile, Lewis acid and Lewis base. State the main type of the reaction and also the specific type of the reaction according to the equation given.